Okay, today we are going to think about 2D array. 2D array is very similar with our regular array. Only one thing different is 2D dimension, for 2D dimension. So when you make a kind of double type array, 2D array, instead of one bracket, you are going to put two brackets. Then you may name it. Today I'm going to name it as a matrix. Then new type again double. One different is you have to give two numbers this time. One is the number of rows, the other one is the number of columns. For convenience, we are going to just name it as the number of rows, number of columns. I'm going to make just a small size, 3 by 2. Then I can think about draw diagram. This is a number of rows. This is a number of columns. When I draw the diagram, this is very similar as we did before, like a matrix is reference. This reference is actually pointing only first array. So this is the first array, first dimension. So it makes only 3 sides, size 3. So I can name index number 0, 1, 2. Then what's the difference is each one is now not a variable, just not storage. It's also reference, which is pointing another array. So this time I'm gonna have size 2. So this is 2. This one I'm gonna index number 0 and 1. This is 0, 1, then 0, 1. Oh, I said the number of rows, the number of columns. So instead of looking this way, we can also think about this way. Then you can see row number 0, row number 1, row number 2. Then each one has column 0, 1, column 0, 1, column 0, 1. So I'm gonna draw like this way. So how can I name it for this one? There are total 6 storages. I'm gonna just shade on the storage. This one is a storage, the other one, second storage, 3, 4, 5, 6. Then how can I access each one? First, you are going to give matrix row number, first one, 0, and column number. If I say row 0, column 1, that means this cell is representing this one. Oh, not this one. This one. Row 0, column 1. So can I access and can I also use this storage to assign a value? Yes. So you can think about to assign a value, you can say like matrix 0, 1 is 5.7. Is it possible? Yes, it's possible. But if you want to do this in array, we recommend to assign the previous storage first. Something like this. Oh, I just want to assign random values for each cell. Then we need two-dimensional for loops. The for loop for 2 dimension. So I may think about nested for loop. One is going through only rows, so I'm going to name it int r. That means represents a row number, starts from 0. Row number is up to 3. Not 3, actually 0, 1, 2, so less than 3, then r plus plus. Oh, do I have to use 3? No, actually we recommend to use something. So first, matrix is pointing the first dimension array. So instead of 3, we want to use matrix dot length. Then I'm going to keep writing the nested for loop. So open the curly brace, another for loop. Now this one is 4 columns. So column is actually 0, 1, 0, 1, 0, 1. So always less than 2. For each row, there are only 0 and 1 column. Yes, again, you can change instead of number 2. Now, we can use matrix 0 dot length. That means matrix 0 is this one. So matrix 0 is another 1D array which has only pointing 2 cells. Or matrix 1 dot length, or matrix 2 dot length. They all have the same length. Or matrix R dot length. Which one is recommended way? Every 2D array guarantees it has index 0. Or you can think about each time R is there, guarantees R exists, so we can use one of them. We do not recommend other numbers. We call that as a hard coding. So I'm gonna redo it here. Go back to nested for loop to assign. So now in the matrix, each row number first, then column number, I'm going to assign math.random. So math.random. It's possible because this is a double type array. Then I can finish it. So up to here, population is done, or assigning value is done. Then if I go back to the first part, we call this as instantiation. Instantiate a array to the array, then populate the array by using nested for loop. It's a very popular traditional way.